Glad to be here with you guys tonight. And we're going to talk a little bit about what we see as the evolution of Bitcoin mining. So we take a lot of time when we think about the progress and the evolution of mining and where we're going as a company and where the industry as a whole is heading. And, I like this quote a lot that, sometimes dreams are wiser than what we think about when we're awake. When we started mining back in 2012, we realized pretty quick that it was going to be necessary to do something different with service and repair. And the way things used to work is when you would buy miners and they would break, you would have to ship them back to Shenzhen. You'd have a 50-50 shot maybe of it actually getting repaired or getting back. And then when it did get back, you had another 50-50 shot that whether it would actually mine again. So we decided that we need to do something different. And in 2018, we launched our service and repair division, which I'm very proud of, and to say today that we are the largest ASIC repair facility in North America, and we service clients across the board. But one of the things that I want to talk about is I want to say thanks before we get started to the Bitcoin Mining Museum and the CoinDad. So if you guys haven't seen that, you should definitely check it out. I'm a firm believer that the folks that preserve our history deserve our gratitude. So thanks to the CoinDad and what you guys are doing with the Mining Museum. So, to tag on to that, we'll talk about how we got started. Right, back in the day, you had chipsets that were 140 plus nanometer. You got around 170 gigahash to 1,000 watts. And it was like a nuclear arms race, right? When you did pre-orders, you would order your miners, they would show up. By the time you got them and you started mining with them, there was pre-orders for the next batch. And if you didn't catch up and you didn't maintain, you get left behind in very short order. Now, when we fast forward to what we've got today, we look a lot alike, right? We're a lot more efficient. We've got efficiencies on the table as high as 22 joules and 144 T, but not much has changed. We're still air-cooled. We still have a high failure rate, and we haven't made the leap yet. So, staying with the idea of being the change that we want to see and living the dreams that we've got, we see a divergence forming in the mining world. What we see is we've got air-cooled units that don't always perform to specification. You've got a lot of efficiency drops when it gets hot. You've got failure rates that are very high, PSUs, hash boards, fans, etc. And a lot of times you have warranty service that isn't up to standard by different manufacturers. And if that's not bad enough, you've got uptime. It's not high enough. You've got ROI calcs that everybody does before they buy miners, right? You're looking at, hey, it's going to take me 26 months to make my money back. I'm factoring in the Bitcoin price. But then you don't realize you're going to have 80% uptime because of the failures you're experiencing. On top of that, we've got a lot of companies who've got a pretty hard rap because of the noise that's associated and the complaints and the local government acting against them. So there's this set of problems that we've got to fix as a group. So what we see happening is we're going to see two groups that come out of this divergence. You're going to see advanced mining and you're going to see traditional mining. Air-cooled, still going to have a low CapEx. It's going to have a larger footprint, faster hardware turnover. They are environmentally sensitive and they're noisy. On the flip side, we're going to see advanced mining like hydro, immersion technology, gives you a much better density in a small footprint. So what we're going to see is things like Bitcoin mines that look a lot like AWS or IBM, where you've got 42U racks, super high density on your mining footprint. They can run in any environment, and they're quiet. So an old Chinese proverb is that water drops pierce stone. So we like hydro. Nothing against immersion at all. It's great tech. We feel that hydro offers some advantages over everybody else in the field. So very pleased to say that in conjunction with HeatCore and MicroBT, what we're providing is a turnkey solution that the industry hasn't seen yet. What HeatCore and MicroBT have designed is a hydro system that allows you to get density that none of us have seen. So in a 1 megawatt footprint, less than 1,000 square feet, what we're seeing is hash rates from 24 petahash to 38 petahash, depending on the models you select. We're also seeing custom control systems that are designed to make sure that they prevent problems that you guys are already thinking about in your head. What if we get leaks? What if the water flow goes south and we can't cool the miners? What if there's a problem? How do we handle it, right? The control system that's in here handles all that on an automated basis. So once the system starts running, there's literally no touches that are required. Automated louvers on the front and the rear of the container that draw in air as necessary to keep the ambient less than 40 C. And the entire plumbing system is stainless steel. So, install, super clean, 2U design. Like I alluded to before, you've got 42U racks like a traditional data center. Custom power distribution built in, so no expensive PDUs to add after the fact. You've got 415 Delta that powers the miners. So in order to power a 10 kW PSU, you need that high level of voltage and the 3-phase architecture. System comes with all the switches and the racks, heat molded hoses, quick connect fittings, ensure no leaks. Now, we did run a test because everybody says, hey, it sounds good, but a lot of us have heard a whole lot of shit before that didn't come true. So what about the numbers? We did a 1 meg pilot in Odessa, Texas. Ambient temps where we ran were 104 to 111 Fahrenheit. In this particular install, we did 80 units of the M53 240T, so 19.2 petahash. Real world numbers, 19.23 to 19.64 petahash. We had PCB temps between 58 and 62 C. So if you guys have ever run, especially Woods miners, you know that they like to kind of achieve parity around 80 C. So we're 20 degrees cooler while it's 111 outside. So that's a 22 C improvement from air-cooled. Chip temps between 90 and 96, when average is 115. So we've got an improvement of 25 C from air-cooled units on the chip temp. Now, details, need the deets. So we provide as much or as little support as clients need. In this particular case, we're taking the products from Shenzhen to the US, importing, delivering, completing an entire setup with a 240T M53s. We're providing US-based support for an entire year, stocking all the parts. So if something does break, it doesn't have to go back to China. You don't have to make emails, support tickets, you call us. So MOQ is 1 meg. That's 100 units at 789K. The 53S++ is an option. These aren't coming out till October, but the numbers that these things produce are crazy. At the 320T stock, MicroBT will authorize the warranty to stay in place all the way through 20% OC. So that means 38.4 petahash or 384 T per unit for the full meg. And that's, so the question becomes like, all right, fantastic. Where are we? What do we do? We're located in North Carolina, just outside Raleigh. And we selected Texas, same reason a lot of other miners did. It's hot, it's difficult environment to run in. It's probably the most hostile place we could pick to mine. So we wanted to test it where it was most difficult. Needless to say, the units exceeded our expectations. So we're very confident in what we're offering. And we just want to run down a quick FAQ. So Raleigh, North Carolina, super convenient for shipping across the whole East Coast, Central U.S. We are the oldest and largest ASIC repair facility in North America, founded back in 2014. And we already operate 11.5 meg in North Carolina. And we repair all the major brands of miners, as well as alpha miner PSUs. But it's still not enough. We get a lot of feedback and a lot of questions from our clients, new and old. Hey, why is it that you guys aren't the mining capital of the world? And we didn't have a good answer. So I'm super pleased to announce to everybody here at Disrupt that HMTech is a thing. So we're opening up our next repair shop in Odessa, just outside I-20, to support all the clients and miners that we've got and the new ones that we're going to acquire in the greater Texas area. So very happy to be there in Texas. We're very happy to be able to offer this hydro solution from MicroBT and HeatCore to clients in the U.S. and Canada. So even though we can only see a short distance ahead, man, there's so much to get done, and we really see the mining industry changing and becoming more of an AWS style, right? So when you've got crazy density and you've got the capacity to have almost 40 petahash in a 1,000 square feet, it's pretty amazing. And the future that we see is more hydro, less touches for the clients and for the data center owners, so a lower staffing cost and a lower OpEx. And what comes after that, now we don't know. But what we do know is that there's plenty that needs to get done, and we're going to be here to help the mining community for the next 10 years. So we look forward to doing it. Come by and see us at booth 57. Thank you very much, guys.